Hello explorers and welcome to another video. Today we are going to talk about OpenObserve. And OpenObserve is a logging framework where you can send your logs, your metrics and so on in order to understand how your system actually behaves and what error you get and so on. So it's a way of simply searching for information about the status of your systems and aggregate and ingest everything into one system. So if we switch over to my screen here, I have a Debian system, Debian bookworm, and it's the only thing I've installed here is sudo. Other than that, it's pretty vanilla and pretty just off the cuff simple Debian service. I have set it to have 12 CPUs and about 4 CPUs and 12 gigabytes of memory. The reason is that I'm gonna build OpenObserve here. That's my suggested way of installing it. You can download binaries. This system is also something that you can pay for. So you could get an enterprise version that you can run up to 200 gigabytes of logs. And after that, you need to pay for a license. So it's not that expensive if you really want to get into it. But if you are a larger company that has a lot of logs, of course, it comes with a price. You can also use the cloud hosted version and send your logs there. But I want to show you how to use the open source version that you can run locally in a clustered environment. So usually when you install this, it will install it on your machine and use one particular place on your hard drive to save everything. So it stores all the data in that place. It uses an SQLite database and so on. But that is a single node installation. I want to show you how you can run this in a clustered way. Because when it comes to OpenObserve, if you run multiple of them, you can ingest things faster, of course. Because you send all the logs over, it pretty much just flings them down to disk. And then when it has that data on disk, it will run ingestion processes and bring them into streams. And those streams could have a multiple of functions that could work on that data. So you might need multiple of them. So let's start the install process. And one of the things they recommend is to use nuts. Nuts is a way of having a look on what is actually installed on the different services. So it's pretty much a way of aggregating information on I'm here. So it's a lookup table or something like that for services. I have used etcd before and it is very similar, but I think it's a more robust and it's also deprecated for OpenObserve. So etcd is not something we will install. So installing that on Debian is just running sudo apt install nats server, and we supply a password and it will install that. Not much to it. Then I will create a directory and give that some permissions. So opt nuts and giving that the nuts user as permission. So now I could, if I want to, go in and remove the current configuration of NAT server, because I'm going to show you a very simplified version of it. So if we edit that, I could just copy this in. So here we have server name node 1, the port that you are connecting through other services to this cluster, and then you have a cluster name here, and then what the cluster will listen on, which port, and then you have a multiple of routes here to the other services. So you need to install 3 services for this to work, and then you set up a directory for your jetstream, and jetstream is what is used in OpenObserve to store data. So this would be the way to install this and get it up and running and so on. But currently I'm actually gonna take this service and stop it because at the moment I don't want to install 3 servers locally on this machine for this testing purpose. So I'm gonna just bring it up with some Docker. So I will install Docker Compose, and then after that I will create a Docker Compose file that will bring up 3 nodes locally, so I can do everything on one system. So when you install this, normally you will do as I showed you before, and then do that on 3 different hosts. I'm running an OpenObserve locally here where I store my data, and it has 3 of my hosts in my rack behind me running the NAT servers. So that's the real way to install this. Now we're going to show you how to do it on one single host with Docker. And now Docker Compose is installed, so we will create a Docker Compose YAML, and it's gonna look something like this. So it's pretty much version 3.8, and then we have one node here with the ports, then we have the second node and the third node. So that's pretty much it. And if we just do sudo docker compose up as a daemon, it should pull down those images and get it up and running in 3 different instances locally. So now we have this little cluster. So next up, we're going to install some things to be able to compile the OpenObserve. This is something that you don't need if you just download the binaries, but I'm going to go through that. So first we need curl to download a bunch of stuff. We need Git for the repository. We need protobuf compiler. It's a part of the compile step because it uses protobuf internally. We need Node.js for the web front end, and we need Postgres for running a Postgres server that is going to store the metadata for the service. So the OpenObserve will store metadata in Postgres. It will use the drive for temporarily storing the logs, and then it will compress and do other work on it and store it for long-term storage up to 10 years in an object storage. So I've used my current setup down at home with my Ceph cluster, and I create an OpenObserve bucket that I can store data about OpenObserve. So that is we're gonna look into later. So now that was installed, and I realized here that I actually install a newer version of Node directly after I install the system packages. So probably you don't need that. So I will install or download the install script for Node 22. And when you have downloaded it, you should probably go in with Y and read through it to see that everything is up to snuff. But I'm gonna trust it, and because this is a temporary environment, I'm just gonna run it and install the node information in my system. After that, we can run apt get install node.js again, and it will install the newer 22 repository instead. So before I actually installed the dependencies for Node.js, so this will be a very much smaller install for this, of course. And now we're done with that, and OpenObserve is built in Rust, so of course we need to do Rust up and install Rust. And in this case, we're just gonna go with the default installation. So it will download cargo and so on for Rust and install it locally using the exact command that is suggested on the Rust up homepage in order to install Rust. And that was quick. So now we've installed that. It suggests here for bash system to run this script. This is something that is running by bash RC, so we could have logged in and logged out and logged in again, and we would have that already set up. So now we're going to clone the OpenObserve repository, and it's not a super small repository, but it doesn't take that long to actually check out either. So now we go into that directory, and I'm gonna check out a particular version here, 0.15.0 release candidate 5, which is the latest one. You could also go with 0.14.7, which is the latest stable one if you want, but I'm gonna run the latest release candidate here. And first we need to compile the web interface. I'm going to go into the web directory and run npm install to install all the dependencies for the web interface. So now that we have installed all the dependencies, we need to do npm run build in order to build the web interface, and this will also take a little while. There we go. Now the web interface is installed. So we're going to go down to the root directory of OpenObserve, the repository, and we're going to do cargo build-r. And this will be building the release version of the OpenObserve. And this will take about 20 minutes. So it's not that fast to build, at least not on this hardware. If you're running it on a server with a bunch of CPUs and so on, it will probably be a lot faster. But I'm gonna wait for this to finish before we continue with this tutorial. And we are back 30 minutes later. The lawn is watered and it's too hot in here. But let's continue. We're gonna copy the newly built OpenObserve into our USR local bin, supplying a password. Probably didn't type QWERTY correctly, like that. And then we're gonna create an OpenObserve directory. We're gonna create an OpenObserve group and OpenObserve user that we add to that group, and also CAH own the directory to that user and group. Now we need a Postgres database, so let's sudo into our Postgres database, and we will create a user with the password change me now, and a database called OpenObserve, and its owner will be OpenObserve, and we're also going to grant the public schema to that OpenObserve user. So that is the database configured. Now we're gonna configure OpenObserve. So let's go to etc systemd, because I'm gonna run it as a server. And here we're gonna create an OpenObserve.env. So this is gonna be our environment variables. And I'm gonna copy paste a bunch of them into this file. And this is what I put in here. So on my 5th node here, in my Ceph cluster, I have an OpenObserve record, because it's gonna be just for this recording, then I'm gonna waste it. And it's the bucket name is the same here. We have access rights for that bucket. I'm gonna use the force host style. So if you're using S3 online, where they have different data centers and different domains, then you can use the domain style, but now we're going to use the URL style because it's going to be a locally hosted. For some odd reason, you need to supply the bucket name up here. Not really sure why, but that's what I do there. And then we're going to say that the metastore is going to be Postgres, not SQLite. And then we have a DSN for this Postgres against the Postgres database that we just created. I'm going to say that this is not a local mode install. We're going to use the cluster version, which could be multiple servers. So we could do this install on multiple ones. And then we have a root username and password. This is the first username and password that you log in with. You could change the password later on, and you remove these from the environment list. So this is just a first bootstrap, so you actually have a username and password. And then we have created our NATs locally, and then we say that the cluster coordinator is going to be NATs. If you don't set it here, it will use etcd. So that's why we are saying that we want NATs particularly. And of course, I need to do sudo on this, or else it will not work. So let's do that. Copy this configuration again, like that, and store it. Then we're going to create a service. And it's not going to be that complicated either. So this is pretty much a unit, description, OpenObserve service, needs network to be online before we start it, installed, wanted by multi-user, and then we have the service, a working directory. This is where the temporary data will be stored. So this OpenObserve directory that we created earlier. We have the environment file here for all the environment variables. It's going to be a simple service, which means it will start and kill a service or a particular binary. And then we have the user and group of OpenObserve, delegate yes, and we set the start out timeout for 0 seconds, so it will start directly. always restart and restart in 5 seconds, so it doesn't restart directly. It will do a little bit of a wait before it restarts, and then the actual executable that we want to start. Now I'm gonna do a system control daemon reload here. Let's see, don't want to copy that part here, like that. And then we want to start this. And this could fail now. And there is a good reason for it to fail. If we look at the journal, this is sudo journal, control u OpenObserve E. So here it will stop because it doesn't have the privileges to write to my cluster. And the reason is because the clock is too far out of whack. So it says that the clock is now 5 p.m., but it's actually 3 p.m. here. So it's 2 hours off. And so the best solution for me here is just install an NTP server. So it will actually go out and fetch the correct time. So if we do date again, it should update. There we go. So now we have 3 o'clock instead. And if we do a restart here on the OpenObserve, it should be able to start it up and fully be up and running. So that's an interesting little side thing here. Of course, I have NTP servers installed on all my other machines, but because this is a temporary system that I'm just using for this recording, I didn't plan on installing an NTP server, but during the testing of this script, I had that problem. So I install it. It takes a while to start the OpenObserve first time, but it should be up and running now. Yes. So now we should be able to switch over to my screen here. And now we go to 5. So we go to root, example.com, and we use the QWERTY password. So now I'm logged in, and I'm going to do dark mode. So now, if we look here, we have no data ingested. So no logs have been sent yet. I'm going to show you a couple of ways of actually ingesting logs. One way is to send them directly from some system. I'm going to use curl for that. If we look here at data sources, you see that you have a bunch of different versions here. You can do Kubernetes, Windows, you have Linux here to add things. You could install for Amazon Web Services and so on. You have custom here, so you can curl some, Filebeat. Those two is things I'm going to look at. But then we have a bunch of different here. We could send syslog, just turn that on, and then it will listen for syslogs. We have web service, Nginx, and IIS. I don't know why the Feather web server isn't here. We have databases, pretty much all of them. We have security available for us. We have DevOps, Ansible and Jenkins and so on. NetFlow in networking. We have RabbitMQ and Kafka for those using those kind of services. And then we have a couple of languages here, Python and Node.js and so on. I'm going to show you PHP. I built my own there, or asked ChatGPT and then did some changes, of course. And then we have some other here for Heroku and so on. So if we switch over to my code here, I can actually run PHP test. And this should, it doesn't work if you don't have the right address, of course. We're going to switch that up and send it over. So now we should have something here in the prod organization. So you have organizations here, the default organization. I will use the prod organization. And here we see that we have a PHP log. And if we look in here, we have 2 records. And if we look at the message, so you can click on what columns you want to see. So I can have environment, and then I can have message. So you just send in JSON with a timestamp and some bunch of other fields. And those other fields are things that you could later on use to configure in here. So if you just send it in, and if we look at the configuration here, we see that all of these have gotten the correct typing and so on. And then you could turn on full text search and so on for particular fields. If you send in something that is message, it figures out that full text search on a message is a good thing. And we see here also that we keep it for 10 years, these logs. But then we can, of course, choose a couple of fields here, and we can also go in and say that we want to filter. So I only want to have things from the environment production. And you can say I want to see the last day, and I want it to update every 5 seconds. So those are very simple, small things you can do here. But you have a whole language. You can either use SQL or you can use this meta language in order to search your logs. So there is a lot of power in this for logs. And you can also send in metrics and get different diagrams and so on in this system. If we look at the code in PHP, so I have it here. I pretty much created this flow logger here, and we'll send data over to that with the right permissions. And then I set an error handler here that could take any error from PHP and then set the correct type on that error and send it through to the flow logger. And I also will register a shutdown. And this is not really required because we already set that in the class. And then we type a started program here, and then I have something that will generate an error here as well, get Kalle. And if we look at the logs, we see that it actually threw an exception on that. So undefined array key Kalle, and that is shown in the log as well. If we look at the flow logger, it's pretty much something that, well, what I said to ChatGPT is that I want to have something that keeps the logs in a buffer in memory, and it also gave me Elasticsearch, even though I didn't ask for it. So typical ChatGPT. So I wanted a simple thing that could send off the logs and have them buffered in memory, and then send them off in a separate interval, or if the buffer got too large, and it actually did that. So it's probably because this had been written multiple times before, it was able to do this. So the defaults here are pretty nice. It sets a constructor here with a bunch of different things, that the max amount of messages could be in there, and it will send it off every 2 seconds. And then it had some common variables it sets here, and then this flush will be set as a registered shutdown. So if the PHP application shuts down before it has sent the message, it will trigger this shutdown function and send the message then. So that's important for PHP. Other languages that is always running, this is not really that important, but for PHP it's very important. We have this helpers function here just to set a log message with a particular level, and then we have this logging function that will pretty much send off logs, and if the buffer is full, we will flush the logs. The flushing is pretty much going through here and sending the buffer over to OpenObserve, and then it will set a new last time it actually sent them over. OpenObserve will go through this buffer, create some headings here for the actual basic auth. Basic auth is pretty much the only thing that will work here. So service token and the other authorization doesn't work. And you could create a service user or service account with a username and password and use the basic auth on that. But I haven't seen anything that you could use Bearer or something like that. It works well with the open source version. There is a lot of different options for the enterprise versions, but for the open source, you only have basic auth here. And then we will create a batch with all these messages. So here we see that we set the timestamp, and then we have a bunch of other things that goes into this JSON document. So we create a list of records, and then we will send the whole list here with a HTTP post, and it uses curl pretty much. It's not that much code, and it's not that complicated, but it's a simple way of sending logs over in a controlled fashion. Next up, we're going to check also adding this Filebeat or the Filebeat to actually read files on disk. In order to do that, we need to install vget. So can get the actual key. So we will vget the key from Elasticsearch here into memory or our key database, and then we will set the Elasticsearch here, because Filebeat is a part, or Filebeat is a part of Elasticsearch. Then we can install Filebeat and also the HTTP transport HTTPS. I think it's already installed previously, but we at least install Filebeat, so we will have that binary available. And it will give us a configuration file, but that configuration file expect that we are sending logs locally to localhost, and that is not something that we want to do. So I will replace that configuration with my own configuration, and it will be very simplistic, not that complicated. So we will move that away, and then we will edit our own file, and this YAML file will look something like this. So we will disable a couple of features up here. We will say that the Filebeat input will be a file stream. We will enable it. Ceph logs isn't correct here. I used it for Ceph logs in my own installation here, so this will be system logs. And then we will have varlog logs, all the log files down there, and we will have an output of Elasticsearch. So what they have done is implemented a bunch of different APIs that is already available. So we are using Filebeat that sends to Elasticsearch, but we are using that endpoint and sending data to OpenObserve instead. So we will just use our local host here, and we will do it every 10 seconds. We will have this API path default. So what we are saying here that we want to send it to the default organization into the default stream. And then we are using my username and password here. And so everything in the OpenObserve is in an organization, and then we have multiple streams in that organization. So if we now do a reload and restart Filebeat, we see that it is up and running. And we can switch over to my OpenObserve here and go back to home. We switch over to the default organization. We see that we have a stream here, and this stream has some logs in it. So it has sent over all these file logs here with all the things that were happening in my log files for this particular computer. Other things that you can do in this program that is interesting is pipelines. So here you can create a pipeline where you take one stream, run a function or a condition on that stream or query, and then send that over to a new stream. So this is a way of changing data on the fly in the system, so you get different views on the same data. So getting all the raw data into the system is one thing, but then you have a lot of different tools in order to refine that data. You could also create reports on that data and alerts on that data, sending emails or webhooks when a particular thing happens in your system. So this was OpenObserve that I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you have any comments or suggestions, leave those in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.